Till which topic have we completed?
Ma'am, we haven't started this topic.
Yes. Ashad, what did you say?
Ma'am, we didn't start these topics, ma'am. Reactivity series, we are behind.
We have done this placement reaction.
No, ma'am.
Yes.
We have done in the last class.
Yes, we did.
Yes.
Oh, yeah.
We have done, right? Based on all the reactions, reaction with water, reaction with air, reaction with acids, and this displacement reaction, we have come up with a series of metals, list of metals. And in this, the elements, the metals are arranged in order of decreasing reactivity. So you can see that potassium is the most reactive metal. That's why it is kept at the top of the series. And gold is the least reactive metals. Now tell me, hydrogen is a metal or a non-metal?
Not a metal,
It
non-metal.
is a non-metal, but
It is used to measure.
yes, it is a non-metal and it loses electrons. All the metal loses electrons. Similarly, hydrogen also loses electrons, and hydrogen forms H plus ions. And all the metals form cations. That's why hydrogen is kept in this series for comparison. So the elements which are present above hydrogen in the series, they are more reactive than hydrogen. And the elements which are present below hydrogen in this series, they are less reactive than hydrogen. Like if I am saying that this metal is reactive. So reactive for metal means that it can lose electrons easily, because metals have a tendency to lose electrons. They form cations. So if a metal is more reactive, that means it can easily lose electrons. And if a metal is less reactive, that means it cannot so easily lose the electron. Is it clear?
Yes, ma'am.
Yes.
So reactivity in this sense. Do you remember the names of first 20 elements? Yes or no?
Yes, ma'am.
First one is hydrogen. Quickly tell me one by one the list of elements. Hydrogen,
Helium,
helium, then
lithium,
lithium,
beryllium,
beryllium,
boron,
boron,
carbon,
carbon,
boron, carbon, nitrogen,
nitrogen,
oxygen,
oxygen,
fluorine, neon,
fluorine, neon,
sodium, magnesium.
sodium, magnesium.
Sodium, magnesium.
Anyone else will also speak?
Aluminium,
Aluminium,
then silicon,
silicon,
phosphorus,
phosphorus,
sulfur,
sulfur,
argon,
chlorine,
chlorine, argon, potassium and calcium. Hello, potassium and calcium.
potassium and calcium. So first 20 elements should be on your tips. So do you know how to write the electronic configuration?
Yes, ma'am.
Okay, so Jaslyn, can you tell me the electronic configuration?
From the beginning,
Yes, from the beginning.
for hydrogen, 2,
It is 1
1,
because hydrogen is 1, helium will be 2.
2.
What is the maximum capacity of K shell?
2,
2 electrons. Now the next electrons will go into the L shell. And what is the maximum capacity of L shell?
1. No, 8.
8, correct. Madiha, tell me the electronic configuration of lithium. Madiha, are you there? Electronic configuration of lithium. Harshid. Yes, it's correct. Justin, 2, 1. 2 electrons will go in K shell, 1 electron will go in L shell. Beryllium will be 2, 2. Boron has 5 electrons, so 2, 3. Carbon will be 2, 4. Nitrogen 2, 5. Oxygen 2, 6. 2, 7 and 2, 8. This much is clear?
Yes, ma'am.
Yes, ma'am.
Now Rizwan, tell me the electronic configuration of sodium. Tell me. Sodium, K shell will have 2 electrons. L shell will have 8 electrons because maximum capacity of L is 8. Now the 11th electron will go into the M shell. So magnesium will be 282.
8, 2.
Yes. Aluminium will be 283. Silicon 284.
2, 8, 5, 2, 8, 6.
Now this will be
2881.
2881. And this is 2882. So electronic configuration you already. Now do you know what is valency?
Yes, ma'am.
Yes, yes, ma'am.
Yes. What is valency?
Combining capacity.
Yes, combining capacity, or the number of electrons lost or gained by an atom. Now you know that hydrogen can lose 1 electron, it can gain 1 electron. So it can form H plus also, it can form H minus. So the number of electron lost or gained to complete the outermost shell, because for hydrogen the outermost shell is K shell. So to complete the to complete the outermost shell doublet, it needs just 1 electron or it needs to lose 1 electron. So valency will be 1. Now helium has completely filled outermost shell. K shell has a maximum capacity of 2 electrons and helium already has 2 electrons. So it doesn't need to gain electron or lose electron. That means it is stable. So the number of electrons lost or gained by helium is 0 because it is already stable. So it will not lose or gain electrons. Now lithium. Lithium has 1 electron in the L shell. Now L shell has a capacity of 8 electrons, maximum capacity. So lithium cannot gain 7 electrons. That is very difficult for lithium. So it will lose 1 electron to make its K shell completely filled. So it will lose 1 electron and form a cation. That is Li plus. So number of electrons lost is 1. So valency will be 1. Similarly, beryllium will lose 2 electrons to become stable. So its valency will be 2 because 2 electrons are lost. Boron will lose 3 electrons. So its valency will be 3. Carbon is a special case. It needs 4 more electrons to complete the octet. So its valency is 4. And in this case, it will neither lose electrons nor gain electrons. It will share electrons. And in chapter 4, we'll study about this in detail, about sharing of electrons. Now, so remember that one element having 1, 2 or 3 electron in the outermost shell will lose electron and it will form a cation. Now, if we talk about elements which are having 5, 6 or 7 electrons, they will gain electrons to complete their octet. So nitrogen needs 3 more electrons to complete its octet. So it will gain 3 electrons, it will form N3 minus. So valency will be 3. Nitrogen will gain 2 electrons, so valency will be 2. Fluorine will gain 1 electron, it will form F minus, so its valency will be 1. Now you can see that neon has completely filled outermost shell. So it is stable, it will not lose or gain electrons, so its valency will be 0. This much is clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now see, sodium has 1 electron and the capacity of M shell is again 8 electrons. So 7 electrons are difficult to gain. So it will lose 1 electron, it will form Na plus, valency will be 1. Magnesium will form Mg2 plus, valency will be 2. Aluminium will form Al3 plus. Silicon is also a special case, it will share electrons. Any atom which is having 4 electrons in the outermost shell, that will share. So its valency is 2. Phosphorus, elements having 5, 6, 7 electrons will gain. So phosphorus will gain, it will form P3 minus. So valency is 3. Sulfur will gain 2 electrons, S2 minus, so 2. Chlorine will gain 1 electron, so 1. Argon has completely filled shell, so it is stable. So valency will be 0. Again, potassium will lose 1 electron, K plus, valency is 1. Calcium will lose 2 electrons, valency will be 2. All this is clear to you?
Yes, ma'am.
Yes.
So the atomic numbers, the electronic configuration, the symbol of the ions, the valency, this should be on your tips. Now observe helium, neon, and argon. Helium is having atomic number 2, argon is having atomic number 10, and sorry, helium 2, neon 10, and argon is 18. So it is 2, K shell is fully filled. In this, L shell is completely filled, and in argon, M shell is completely filled. So the atoms which are having completely filled outermost shell, and outermost shell is also called as valence shell. This you remember?
Yes, ma'am.
Yes.
Yes,
So
yes.
all the atoms which are having outermost shell completely filled, they are called as noble gases, or they are called as inert gases, because they are very unreactive. They already have completely filled shells, so there is no need for them to lose or gain electrons. That's why they don't react with anyone. Like in this universe also, in this world also, everyone wants to become stable. Similarly, these atoms also want to become stable. And for atoms, stability means that they have completely filled outermost shell. So every element other than these noble gases, they also want to attain completely filled outermost shell. That's why they combine with one another. They react with one another so that they can achieve noble gas configuration. They can become like noble gas. They can become stable. That's why they form bonds. Now, an atom can achieve these noble gas configuration. They can become like noble gases. They can achieve completely filled octet by 3 ways. First is they can lose electrons, they can gain electrons, or they can share electrons, right? So these are the 3 ways in which an atom can achieve noble gas configuration. Now, if an atom loses electrons, it forms cation, that are positively charged ions. And if an atom gains electrons, it will form anions, that is negatively charged ions. And sharing electrons will be discussed in chapter number 4. So right now we have to just discuss loss of electrons leads to formation of cation, and gain of electrons leads to formation of anion. This much is clear?
Yep, ma'am.
Ma'am.
Oh. So we have to study about how do metals and non-metals react. So whenever metal reacts with a non-metal, they always form ionic compound. Like if we take the example of a metal, metal is sodium, and suppose non-metal is chlorine. So sodium is atomic number 11, 281, and chlorine is atomic number 17, 287. Now, in order to be stable, sodium will lose 1 electron. And in order to be stable, chlorine will gain 1 electron. So sodium loses 1 electron to form Na plus. It will become now 2, 8, and it has lost 1 electron. This one electron can be taken by chlorine. So chlorine is 287. It can gain one electron and become Cl minus anion. That is 288. So sodium is your metal and chlorine is a non-metal. So metal loses electron, forms a cation. Non-metal gains electron and forms an anion. So you can notice that there is a transfer of electron from metal to a non-metal. There's a give and take relationship. So metal is losing electron, non-metal is gaining electron. So this transfer of electron from metal to non-metal gives rise to ionic bond. It leads to the formation of cation and anion. And you know that oppositely charged particles, they attract each other. Cation is positively charged, anion is negatively charged, and opposite charges attract each other. So there's a strong force of attraction between this cation and anion, and they are held together. So the strong force of attraction between the oppositely charged ions, it is called as ionic bond. And the compound formed by these two ions, like Na plus and Cl, after gaining electron, has become NaCl minus. So this Na plus and Cl minus is an example of ionic compound. So if there is any compound in which metal and non-metal is present, that is an ionic compound. Because whenever metals react with non-metals, they form ionic compounds. And the force of attraction which is there, which is holding these ions together, that is called as ionic bond. Is it clear?
Yes, yes, sir.
Okay. Now you remember that atomic number is equal to number of protons, number of electrons, right? So sodium is having 11 atomic number. So sodium atom will have 11 protons, it will have 11 electrons. But when it has been converted into a cation, so it has left with 11 protons and 10 electrons, because one electron has been lost, it has been given up. So number of protons remains the same, while the number of electrons reduces in the formation of cation. Now if we talk about chlorine, so chlorine atom has 17 protons, 17 electrons, equal to the atomic number. But when it has gained electron, it will lead to 17 protons and 18 electrons. So you have to remember that anion contains more electrons than normal atom, whereas cation contains lesser electrons than normal atom. Is it clear?
Yes.
An atom contains equal number of protons and electrons, but in the formation of ions, the number of electrons reduces or it increases, because cation is formed by loss of electrons. So in cation, the number of electrons will decrease. Anion is formed by gain of electrons. So in that anion, number of electrons will increase. Now, if I ask you that you have Na plus and you have Na, which is having more electrons?
Na,
Yes, Na will have more electrons. If I talk about Cl minus or Cl?
Cl minus,
Cl minus. Okay. Oxygen or O2 minus?
O2 minus,
Yes, anion will have more electrons, cation will have lesser electrons. So ions are charged particles which are formed by the loss of gain of electrons. And atoms combine to achieve their octet, to make their outermost shell completely filled. So we have studied in the first 20 elements that there are 3 examples of noble gases: helium, neon, and argon. You have to remember these examples. So noble gases have completely filled valence shell. Valence shell means it is outermost shell. And because of the completely filled outermost shell, they don't react with any other elements because they are already stable. They don't need electrons. They don't need to lose or gain electrons. That's why they show little chemical reactivity, or we can say that they are unreactive. Now, reactivity of elements means that every element has a tendency to attain a completely filled valence shell. Every atom wants to achieve a completely filled valence shell. That's why they react with one another. Is it clear? Have you understood the cause of chemical combination? Why do atoms combine with one another?
Yes, ma'am. To make them stable.
Yes, to make them stable, and stability means that their outermost shell should be completely filled, just like noble gases.
Yes.
So we have discussed this table. We have discussed all the first 20 elements, but in NCRT only some of the elements are given. Like in the first 20 elements, there are 3 noble gases, helium, neon, argon. So you have to remember their atomic number as well as their electronic configuration. We have discussed metals, sodium, potassium, calcium, aluminium, magnesium. All these are examples of metals. So you have to remember their configuration and atomic number. Non-metals are nitrogen, oxygen, fluorine, chlorine, phosphorus, sulfur. So we have discussed all the elements which are till 20 atomic number. So you can go through this table. Now see here. We have already discussed the example of sodium chloride. Sodium is metal, chlorine is non-metal. Sodium will lose electron, form Na+, chlorine will gain electron, form Cl-. So sodium is 281, it will lose electron, form 28, sodium cation. Chlorine will gain this electron, 287, it will become 288, that is chloride anion. So Na plus is losing electron, Cl minus is gaining electron. So Na after losing electron forms Na plus cation, and Cl minus forms Cl minus after gaining electrons. So this way you have to represent the formation of an ionic compound, that there is an transfer of electron from a metal to a non-metal. This is a metal, this is a non-metal. So there's a transfer of electron from metal to non-metal, and that leads to the formation of charged particles which are called as ions. Cations and anions are there. Here also in this figure you can see that the metal is donating the electron to a non-metal. There's a transfer of electron. So such type of compound is called as ionic compound, in which the transfer of electrons takes place. And because of the formation of cation and anion, opposite charge attracts each other. There's a force of attraction between these two, which is called as ionic bond or electrovalent bond. So you can see that sodium ion is there, chloride ion is there, and both of them are oppositely charged, and opposite charged ions attract each other. And there's a strong force of attraction, which is called as ionic bond or electrovalent bond. And they exist as NaCl. So if somewhere NaCl is written, that means Na plus and Cl minus. Cations and anions are there. So sodium chloride is an ionic compound. No molecules are there. Instead of that, ions are present. It is a collection of ions. It is an aggregate of oppositely charged ions. This much is clear.
Yes, ma'am.
Now you can note down this about sodium and
Perfect.
chlorine and these 2 points.
Excuse me, ma'am.
Yes, Rizwan.
Ma'am, can you explain in that third that chlorine thing, right? It like
This
has
one,
cross
this one.
symbol.
Yes, yes. See, only the outermost electron, these valence electrons participating bonding. Whenever chemical bond formation takes place, only outermost electrons, valence electrons participate. So we have denoted sodium atoms by a dot, okay, and we have denoted 7 valence electron of chlorines by a cross, so that we can distinguish between electrons of sodium and chlorine, so that there's no confusion. Is it clear? So these
Yeah.
electrons or these crosses, they just indicate valence electrons which are participating in the formation of chemical bond. Okay.
Yes, sir.
Have you written these points?
Yes.
Okay. So ionic bonds are like this. This is the structure, 3-dimensional structure in which cations are surrounded by anions. So you can see that cations are surrounded by anions and anions are surrounded by cations. So these are aggregates. So many positively charged and negatively charged ions are present. No molecules are present. So whenever in a compound there is a metal and a non-metal, that means it is an ionic compound. So the compounds which are formed by transfer of electrons from a metal to a non-metal, they are called as ionic compounds or electrovalent compounds. So the example is sodium chloride, NaCl. Sodium is metal, chlorine is a non-metal. So there's a transfer of electrons from a metal to a non-metal, and it gives rise to the formation of ionic compound. Is it clear?
Yes, ma'am.
Okay, so write down the definition of ionic compounds and the example. Written?
No, ma'am. Done, ma'am.
Then
Okay. So this is one more example of ionic compound, that is magnesium chloride, MgCl2. So you have to look at its formation. Like this comes to draw in your exams, like show the formation of ionic bonding, how the ionic bond formation takes place in this compound. So for sodium chloride, we have already discussed. Now we'll discuss for magnesium chloride. So magnesium is your metal, chlorine is a non-metal. So there will be an ionic bond formation. There will be a transfer of electron from metal to non-metal. So first we'll write down magnesium, write down the electronic configuration 282. So magnesium can lose 2 electrons. It can become stable. It will form Mg2 plus and 2 electrons will be lost. And while writing the formula, you can observe that there are 2 chlorine atoms. There is 1 magnesium atom and there are 2 chlorine atoms. So magnesium has 2 valence electrons. So we'll show the valence electrons by a dot, by 2 dots. And to distinguish the electrons of chlorine, we'll show it by a cross. So chlorine has 7 valence electrons and there are 2 chlorine atoms. So we'll draw 7 crosses on each chlorine atom. 7 crosses, that will show 7 electrons. Now 1 electron will be donated to this chlorine atom so that it becomes stable, and the other electron is donated to this chlorine atom. So Mg, after losing 2 electrons, it will become Mg2 plus, and Cl after gaining 1 electron, it will form Cl. Now 8 electrons are there, and it will gain a negative charge, and Cl minus are 2. So this will be called as Mg2 plus, and Cl minus is twice. So it can be written as MgCl2. Is it clear?
Yes, ma'am.
So this is how you have to show the formation of ionic bond. Now suppose if I say that show the ionic bond formation in potassium chloride, KCl. So potassium is metal, chlorine is non-metal. So this will be an ionic compound. So can you show the electron transfer? Electronic configuration of potassium will be 2881. After losing 1 electron, it will become K plus 288. And Cl is 287. It will gain 1 electron. It will form Cl minus 288. So potassium is having 1 electron. Chlorine is having 7 electrons.
So 7 crosses.
Yes. So potassium will donate 1 electron. It will give its 1 electron to chlorine. It will form K plus, and Cl will now have 8 electrons. It will become Cl minus. So this is how you have to show the formation of ionic compound. Is it clear?
Yes, ma'am.
Now we have to study certain properties of ionic compounds. So there are 4 points. First is the physical nature. Second is about melting and boiling points. Third is about solubility. And fourth is about conduction of electricity, whether it will conduct electricity or not. So first one is that ionic compounds are solids. You know that sodium chloride, common salt which we use in cooking, that is also an example of ionic compound, and that is a solid. The crystals are there. So ionic compounds are solid and they are hard. Hard because of that ionic compounds are made up of ions. There are 2 types of ions, cation and anion. And opposite charged ions attract each other. There's a strong force of attraction between the oppositely charged ions. So because of this strong force of attraction, they're having a proper crystal structure. They have this type of structure. They're surrounded by cations and anions. So they are hard. So they are solids, they are hard because of the strong force of attraction. And they are brittle. That means they can break into pieces when pressure is applied. So this is the first point. Now, if we talk about melting and boiling points, so they have high melting and boiling points. Like sodium chloride has a high melting point, high boiling point. And these ionic compounds are made up of ions, and there's a strong force of attraction between these oppositely charged ions. So a lot of heat is provided, it is required to break the force of attraction between these compounds and to melt them or to boil them. So it's written that large amount of energy is required to break the strong interionic attraction. Interionic attraction means attraction between the ions, attraction between the oppositely charged ions. So the force of attraction is high, large amount of energy will be needed. That's why high melting and boiling points are there. Next is solubility. So ionic compounds are soluble in water. Like you know that salt is soluble in water. It can easily dissolve in water, but they are insoluble in solvents like kerosene, petrol, benzene, carbon disulfide. There are so many solvents, so they are insoluble in those solvents. Fourth point is related to conduction of electricity. So ionic compounds can conduct electricity when they are dissolved in water or when they are melted. You remember electrolytes? Any compound that can break into ions. If in any solution charged particles are present and the movement of charged particles give rise to electric current. So conduction of electricity through a solution, it involves the movement of charged particles. Ions should be present and the flow of ions will give rise to electric current. Now, ionic compounds in the solid state, they are made up of ions, but they do not conduct electricity in the solid state. Because in the solid state, the ions are held together in fixed position. They are in their fixed position. They are not able to move freely. And if they are not able to move, there will be no electric current, no conduction of electricity. But when we melt them, we provide energy to them. So by providing energy, the ions start moving freely because their force of attraction is overcome by heat. Now they can move freely, and if the ions are moving, that means electric current is there and there is conduction of electricity. So a solution of an ionic compound in water. Suppose you're having an ionic compound NaCl and you have dissolved it in water. So you know that in the presence of water, this compound will break into ions. It will form Na plus and Cl minus. So a solution of ionic compound in water contains ions. So ions are oppositely charged here, and when you have connected them to the battery, so you know that there are two terminals, positive terminal and negative terminal. So the positively charged ion will start moving towards the negatively charged ion, and negatively charged ion will start moving towards the positively charged ion. That means these ions move to the opposite electrodes, positively charged or negatively charged, when electricity is passed through the solution. So by this movement of charged particles, electric current generates. So ionic compounds in the solid state do not conduct electricity because in the solid state, the position of ions is fixed. It is not possible. The movement is not possible because of their fixed structure. But if they are melted, so in the molten state, the force of attraction between the ions, they are overcome due to the heat supply. So the ions start moving freely and then they will conduct electricity. So you have to remember that ionic compounds conduct electricity in solution, that means in water, or when they are melted. But when they are in solid form, in the solid state, they do not conduct electricity because the ions are not free to move. Are these properties clear to you?
Yes, ma'am.
Okay, so note down these properties. You can write in short. But the reasons are important. You have to write the reasons. Have you written?
No, ma'am.
Okay, once you are done, please tell.
Okay.
Done, ma'am.
Write down these points also.
Done, ma'am.
Done, ma'am.
Is it done?
Then yes, ma'am.
Yes, ma'am.
This topic is done. Now we'll discuss some questions. Can you see the previous year's questions?
Yes, ma'am.
Yes, ma'am.
This is a topic, how do metals and non-metals react? So first question is, give reason for the following observation. Ionic compounds in general have high melting or boiling points. So these physical properties of ionic compounds comes in the form of reasoning. Like you can say that ionic compounds are solid and hard, give reason. Or they have high melting and boiling points. So you have to explain the reason. So can anyone tell me why they have high melting and boiling points? Yes, can you tell?
Because a large amount is required to break the strong inter-ionic attraction.
Yes, correct. Large amount of energy is needed to break the force of attraction between the ions. Correct. Now, second question. Can you show me the formation of Na2O, sodium oxide, by the transfer of electrons? Just as we have discussed NaCl and MgCl2, KCl. Similarly, you have to write down for Na2O. Will you be able to do this? Yes or no?
Yes.
So try it right now. Have you done? Now see, there are two sodium atoms and sodium has atomic number 11281. So there is one valence electron in both the sodium atoms. And we have oxygen. Oxygen has atomic number 8, 2, 6. That means it has 6 valence electrons, right? Oxygen needs 2 more electrons to become stable. So one sodium atom will donate this electron, another sodium atom will also donate the electron. So we will have Na plus, 2 Na plus are there, and O2 minus. Oxygen has gained 2 electrons Number of electrons have become 8 now, and it has gained 2 minus charge. So it will become Na plus whole twice and 2 minus. Is it clear?
Yes, ma'am.
Okay. Second question is, why are ionic compounds hard? So this I have already made you write. How is it that ionic compounds in the solid state do not conduct electricity? Because the ions are fixed at the position, they cannot move freely. That's why they do not conduct electricity. And when they are in molten form, so the heat has broken the force of attraction between the ions. Now the ions can move freely, and hence they can conduct